Hello, geometry students. So today we're going to take a look at the Pythagorean Theorem, but we're going to take a look at it in terms of radicals. So remember, the Pythagorean Theorem applies to a right triangle, and if the legs are represented by, by the variables a and b, and your hypotenuse is the variable c, remember a squared plus b squared equals c squared. Or, like I like to think about it, leg squared plus leg squared equals the hypotenuse squared. Remember, the hypotenuse is always the side across from the right angle. So we're going to take a look at just two examples because it works the same way. We've been doing radicals all week, so we're kind of putting it all together. So in this first one, it says from the length of the third side, if necessary, write it in simplest radical form. So you're not telling me what it is as a decimal. You're going to keep it as a radical and then simplify as much as you can. So in this particular picture, my hypotenuse is this missing side here. So that's my C. The other two are my A and my B. It doesn't matter which one's which. It's up to you. So again, according to Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, or A squared plus B squared equals C squared. So we have here 5 squared plus 2 root 6 squared equals c squared. And we're going to work it out here. So 5 squared is 25. We talked about squaring radicals yesterday. Remember, this is like saying 2 root 6 times 2 root 6. Okay? Working that out, 2 times 2 is 4. And the inside, 6 times 6 is 36. And again, if I continue this here, this is really 4 times the square root of 36 is 6. And 4 times 6 is 24. Okay, so now that we got that figured out here, let's keep going. So if I combine like terms here, 25 plus 24 is 49. So if c squared equals 49, to find c, I'm going to take the square root of both sides. And 49 is a perfect square. The square root of 49 is 7. So I don't have to worry about simplifying anymore because, again, it was a perfect square. Now realize they're not all going to work out that way, but that one will. Okay, the other one I have, same kind of problem. We are trying to find a missing side here. So this one is my hypotenuse. It goes by the variable c if I'm thinking about a squared plus b squared equals c squared. And that means that this leg, we'll call it a or b. It doesn't matter which one's which. So again, according to Pythagorean theorem, we'd have a squared plus 9 squared equals 3 root 13 squared. Okay, so 9 squared is 81. Remember when I square 3 root 13, it's like it's multiplying it by itself. Okay, so again, we have a squared plus 81 equals, well, 3 times 3 is 9. And the square root of 13 times the square root of 13 is the square root of 169. Okay, and we know that the square root of 169 is 13. So really, it's like we're multiplying 9 times 13. And if you need a calculator, that's fine. 9 times 13 is 117. So if I'm going to continue solving for a, I'm going to subtract 81 from both sides. So a squared equals, if you take 117 minus 18, it is not 18, I'm sorry. I'm thinking one thing and saying another. So if you take 117 minus 81, that gives you 36. And then to find a, we're going to take the square root of both sides. So a is going to be 6. Now again, some of them will not be integers. Some of them you will have to simplify in the end. And that comes back to what we were doing the other day. So for example, let's pretend, off to the side here, let's pretend I get a to be the square root of 24. Well, I want to reduce this, okay? So if I do that, it's not a perfect square, but it does have a factor that is. It is 4 times 6. So my answer here would be 2 square roots of 6. That is not related to either of these two problems, but it is a possible answer you could end up with. So again, if this is not a perfect square, and these two examples that I picked, they were perfect squares. But if it's not, you need to break it down and simplify. Today's assignment is in Delta Math, If you would type it in as the square root of 24, it probably would mark it wrong because it wants it in simplest form. Okay, so today, again, we're doing Pythagorean theorem with radicals. If you have any questions, please let me know. Bye.